Hey y'all, Miss Stewart here. We are going over writing equations from contextual problems given tables, graphs, and just situations. So let's take a look at this first one here. Luke's family goes to the movies and purchases a large popcorn. They're debating whether to purchase any drinks. The table shows the total cost based on the number of drinks they decide to purchase. Okay, so they're purchasing popcorn no matter what, and they're trying to decide if they need to order drinks. Do they order 0, 1, 2, 3, 4? And you can see this table listed out based on their situation. Okay. So the number of drinks, if they order 0, their total cost would be $6.25. Okay. And then you can see if they order one drink, their cost now becomes $10. Okay. If they order another drink, so they order two drinks, it becomes $13.75. So we can determine from this what the cost of the popcorn is, okay? And we can also determine what the cost of each drink is, okay? And my change in y value, so we've got drinks is x and total cost is y. So we're looking at our y-intercept or slope-intercept form as y equals mx plus b, okay? And my y-intercept, you can see immediately from the table when x is 0, the y-intercept is um, my y value. So $6.25 is my y value, or my y-intercept rather. And then my slope is going to be that change in y over the change in x. And you can see the change in x is 1 each time. So from 625 to $10, it increases by $3.75. Okay. So and three cent from 10 to 13.75 is $3.75. So that change or that rate of change is 375. So that is your slope, 375 over 1. Now, we need to relate those back to our problem on if my slope is $3.75, what did that mean in the context of the problem? Okay, well, each drink I bought increased my price by $3.75. So $3.75 is the cost per drink or for one drink. Okay, so you can relate that slope, the amount it changes per additional drink you order. Okay, and so you often see that written as per drink, and that's for one because it's $3.75 for one drink. Okay. Now the y-intercept was $6.25, and that was their cost before they bought any drinks. Okay. And the only thing they bought before drinks was this large popcorn. So that means $6.25 is the cost of popcorn, okay, for this particular problem, okay? You might also see that the y-intercept is a fee, or it's just a rate that you pay no matter how much of the other thing you buy, okay? If you go to the gym, you might pay a startup fee of $99, and then you only pay $10 a month after that. That startup fee would be your y-intercept, okay? So this is how you get your equation from a situation involving a table and what those numbers mean corresponding to that situation. Okay, let's take a look at a different type of problem. We're going to look at this one, and this one is just giving you the situation flat out. It says Carly wants to buy some fish to keep in her room. At a local pet store, the customers can pay $12.50 for the fish tank and 20 cents for each fish they purchase. Okay, write an equation to represent the relationship between T, the total cost, okay, and N, the number of fish purchased. Okay, so T, they want us to use T instead of Y, and T would be the total, equals something, so M, and then X is the number of fish, so they want us to use N this time, plus b. Okay, we're still using m for our slope and b for our y-intercept. Now, remember, m is the coefficient to n, which means it's the thing that's being multiplied by the number of fish you decide to buy. Well, the cost of each fish is going to be your slope there. So m needs to be this 0.2 or 20 cents, okay? And that is the cost for each fish, all right, is the slope, all right? And then it says we pay $12.50 for a fish tank. Okay, you're putting all the fish in one tank, so we're buying one fish tank, and that is $12.50. That is the constant. Okay, that does not change based on how many fish you buy, right? You buy one tank and you put all the fish in the tank. All right, so you have $12.50. That is your y-intercept. So that means your equation is t equals 0.2 n plus 1250, and that would be your equation there. Okay. Again, t and n are just y and x. All right. You can use different variables based on the situations that you have. Um, in this case, they wanted t for total cost, so t is the total, and then n is the number, so they used n for number of fish you purchased. Okay, so you can still use x and y; it's not a big deal, but that is why I have used the variables t and n, because that is what they asked us to do in this particular equation. Okay, number 9 is very similar to that, so you can try that one on your own right there. Okay, and let's take a look at one more type of problem. Okay, this one has a graph involved with our contextual problem. This one says Robert pays for his family to go to the arcade. He pays an entrance fee for his group. Okay, so that's one amount of money for the entire group. Okay, and an additional amount per game. All right, so each game that they play, you pay additional amount of money. Okay, that his family plays as shown in the graph. So we're looking at the graph to find our answers. Okay. So if they play zero number of games, they just enter the arcade, it costs, it says, $12. The total cost would be $12. Okay. If they pay, let's see here, I can't tell exactly where that crosses, so I'm going to come all the way over here. This one perfectly crosses at that point and actually up here again at this one. So if they play 4 games, it'll now cost $15. So we need to pay attention to our axes to see what our increase is in our total cost for the number of games that it also increases. So we can see here to go from 12 to 15, I increased my cost by $3 for every 4 games I play. Okay, so my slope here is 3 over 4, and it is a positive slope here. Okay, so it says find the slope, and we found the slope. It's 3 over 4. And I just kind of talked that out on what that means is the increase was 3 in dollars, because you can see the y-axis has the total cost. Okay, so for every $3, they play 4 games, play 4 additional games. Okay, which also means each game is 75 cents per game. Okay, if we simplify that and get a decimal, all right, 3/4 is 75 cents. Okay, so 75 cents per game is going to be the unit rate, or that slope there. Okay. So now my y-intercept is where it crossed that y-axis. Well, when x was 0, when we played 0 games, it cost us $12. So my y-intercept was 12. And they called this an entrance fee, is the fee to get into the arcade. So that we were playing no matter how many games that we played. Okay. So that makes my equation, right, an equation between x, the number of games, and y, the total cost. So y equals 3/4, okay, x plus 12. You could also write this as y equals 0.75x plus 12. Either one of those would work just fine, whether you have it in fraction form or decimal form. Okay. Find fraction form easier to use just because it's much easier to graph, but you can always turn your decimal into a fraction and graph it from there. No big deal.